What if I told you that in exactly 759 billion years, the sun will expand into a red giant and literally cook every living thing on Earth into ash? But here's the twisted part. That cosmic apocalypse isn't even close to being the end of the story. The universe itself has three terrifying ways it could die, and scientists have already figured out which one is going to happen. But before we get to that nightmare scenario, we need to talk about something even more mind-bending. How everything you see, touch, and experience came from absolutely nothing. Right now, every atom in your body was forged in the heart of a dying star. Billions of years ago, the water you drink contains hydrogen atoms that are literally older than the solar system itself. They were born in the first few seconds after reality exploded into existence. But here's what'll absolutely destroy your brain. That explosion didn't happen somewhere in space. It was space, time, matter, energy, the laws of physics. None of it existed until 13.8 billion years ago, when the universe decided to break the ultimate rule and create something from pure nothingness. Scientists call it the Big Bang, but that name is almost insulting to what actually went down. This wasn't just an explosion. It was the moment when existence itself was invented from a point smaller than an atom that contained infinite density and temperatures reaching 1,000 trillion degrees. And then, the universe did something that should be physically impossible. It broke the speed of light and expanded faster than reality itself could handle. But that's just the beginning of this cosmic horror story. Because the way our planet formed involved collisions so violent, they make nuclear bombs look like firecrackers. Picture this absolute madness. Everything you see around you, every galaxy, every star, every planet, every grain of sand, every molecule of oxygen you just breathe, all of it was once compressed into a space so impossibly small that it makes a proton look like the size of a basketball. This wasn't just matter being squeezed together like you'd pack clothes into a suitcase. This was something far more terrifying and beautiful at the same time. Scientists call this the singularity, and it's the most mind-breaking concept in all of physics. At this point, the very fabric of reality itself breaks down. The laws of physics that govern everything from falling apples to orbiting planets literally stop working. Temperature becomes infinite. Density becomes infinite. The curvature of space and time becomes so extreme that our mathematics just gives up and says, nope, can't compute this. But here's what'll make your brain melt. The singularity wasn't sitting somewhere in empty space waiting to explode. There was no space, there was no somewhere for it to exist. Space itself, time itself, the very concept of existence was locked inside this impossible point. Before the singularity, there wasn't darkness, there wasn't emptiness, there wasn't even nothing, because nothing is still something you can point to and say exists. Stephen Hawking and Roger Penrose proved mathematically that if you run the universe backward like a cosmic movie in reverse, you inevitably hit this wall where everything breaks. They showed that the Big Bang singularity isn't just likely, it's absolutely unavoidable, based on the laws of physics as we understand them. Penrose even won the Nobel Prize for this mind-bending revelation. Now here's where it gets absolutely insane. In the first 10 to the minus 32 seconds, something triggered this singularity to explode outward. But calling it an explosion is like calling the birth of reality itself a firecracker. In that incomprehensibly tiny fraction of time, the universe didn't just expand. It underwent what scientists call cosmic inflation, growing from smaller than an atom to larger than a grapefruit, in a time span so short that light itself couldn't even begin to cross the distance. The energy released in this moment was so phenomenally intense that it created temperatures of over 1,000 trillion degrees Celsius. That's hot enough to melt the concept of melting itself. At these temperatures, not even atoms could exist, just pure energy in its most violent, chaotic form. The very building blocks of matter hadn't even been invented yet. And here's the part that should be absolutely impossible. During those first moments, the universe expanded faster than the speed of light. Einstein's theory says nothing can travel faster than light, yet somehow space itself was stretching so rapidly that it violated the ultimate cosmic speed limit. It's like the universe looked at its own rules and said, "Not today," before breaking the most fundamental law of physics. The craziest part, all of this, the infinite density, the impossible temperatures, the faster-than-light expansion, it all happened from a point that contained everything that would ever exist. Every star that would ever shine, every planet that would ever form, every life form that would ever evolve, all of it was packed into that singular, impossible moment. Scientists still can't explain what triggered this cosmic genesis. They can't tell you why the singularity decided to explode, or what caused the laws of physics to suddenly switch on like someone flipping a cosmic light switch. All they know is that somehow, against all logic and reason, something came from nothing, and that something became everything. But the universe wasn't done breaking rules. What happened next would make inflation look like child's play. Einstein spent his entire career proving that nothing, absolutely nothing, can travel faster than light. He won a Nobel Prize for showing that light moves at exactly 2099,000 or 792,458 meters per second, and that's supposed to be the ultimate cosmic speed limit, written into the very fabric of reality itself. Break this rule, and you break causality, you break time, you break everything we understand about how the universe works. But here's the plot twist that'll absolutely demolish your understanding of physics. The universe apparently never bothered reading Einstein's rulebook, because during the first fraction of a second after the Big Bang, it decided to obliterate this fundamental law in the most spectacular, mind-bending way imaginable. Picture this absolutely impossible scenario that actually happened. In the time it takes light to travel, just one tiny fraction across a proton, we're talking about 10 to the negative 37 seconds. Every single distance in the universe doubled. Then it doubled again. Then again. This wasn't just happening once. It was happening continuously, exponentially, relentlessly. The universe was literally manufacturing new space, faster than light could travel through the space that already existed. In just 10 to the negative 35 seconds, the entire observable universe exploded from a region smaller than a proton to something the size of a basketball, then kept going to become larger than a grapefruit. But that's not even scratching the surface of this cosmic madness. By the time inflation finally ended, the universe had expanded by a factor of at least 10 to the 26th power. That's a 1, followed by 2. To put that in perspective, that'll melt your brain. If you took a single atom and it underwent the same expansion, it would become larger than our entire solar system. This theory was first proposed by a physicist named Alan Guth in 1980. And when he first presented it, his colleagues thought he'd completely lost his mind. Guth was basically saying that the universe had committed the ultimate physics crime. It had broken the speed of light, not by a little bit, not by double or triple, but by factors so enormous that our mathematics barely has symbols to express them. Regions that were once close enough to touch became separated by billions upon billions of light years in less time than it takes for a photon to cross the width of a single electron. But here's what makes this even more insane. This wasn't just random cosmic chaos. The universe was being driven by something called the inflaton field, a mysterious energy field that acted like the most powerful rocket fuel in existence. This field was so energy dense that it literally warped space-time itself, forcing the universe to expand exponentially. Every microscopic tick of the cosmic clock, reality itself was doubling in size. The energy involved was so phenomenally intense that it makes the core of the most massive stars look like birthday candles. And here's the part that should be physically impossible. Space itself was expanding faster than light could travel through it. Imagine trying to run forward on a treadmill that's moving backward at 1 trillion times the speed of light. That's what photons were dealing with during inflation. Light beams that tried to travel from one point to another found that the space they were traveling through was stretching faster than they could move. It's like the universe was playing the ultimate cosmic prank on Einstein's speed limit. The craziest part? This faster-than-light expansion solved three mysteries that had been driving cosmologists absolutely insane for decades. First, it explained why the universe looks exactly the same in every direction we look. Without inflation, regions that are now separated by 28 billion light-years should look completely different, because there wouldn't have been enough time for them to exchange information. But inflation showed that these regions were once so close together that they could reach thermal equilibrium before being ripped apart by the expanding space. Second, it explained why the universe is so perfectly flat instead of curved like a ball or bent like a saddle, which is what Einstein's equations predicted. The rapid expansion stretched out any initial curvature so thoroughly that the universe became flatter than a sheet of paper on cosmic scales. It's like taking a wrinkled balloon and inflating it so fast that all the wrinkles get smoothed out completely. Third, it solved the mystery of missing exotic particles called magnetic monopoles. These particles should exist according to our theories, but we've never found any. Inflation explained why. It diluted them so much that they're spread impossibly thin throughout the cosmos, making them essentially invisible. But the most mind-destroying revelation came when physicists realized that quantum fluctuations, tiny, microscopic ripples in the inflaton field that exist at the subatomic level, got stretched to astronomical proportions during this expansion. Those quantum hiccups, smaller than atoms, became the seeds that eventually grew into galaxies, stars, planets, and everything else we see today. Every star in the night sky, every planet orbiting those stars, every atom in your body can trace its origins back to quantum mechanical fluctuations that got inflated to cosmic sizes in those first impossible moments. Scientists have actually detected the fingerprints of this cosmic madness in the cosmic microwave background radiation, the afterglow of the Big Bang that's still flooding through space. The temperature variations they measured using satellites like COBE, WMAP, and Planck match exactly what inflation theory predicted, confirming that the universe really did grow faster than light for a brief impossible moment. The universe is flat to within 0.5%, and it's homogeneous and isotropic to 1 part in 100,000, exactly what inflation predicted. Some physicists, including Guth himself, now believe that inflation might still be happening in other regions of space right now, creating what they call eternal inflation. If this theory is correct, then our entire observable universe, everything we can see with our most powerful telescopes spanning 93 billion light-years, is just one tiny bubble in an infinite cosmic ocean, where new universes are constantly budding off like soap bubbles in an eternal, ever-expanding multiverse. Each bubble universe could have completely different laws of physics, different constants of nature, different possibilities for life and complexity. But here's the terrifying, beautiful part that'll keep you awake at night. According to eternal inflation theory, somewhere out there in the infinite expanse of inflating space, there are regions where inflation is ending right now, creating brand new universes with their own big bangs, their own physics, their own possibilities for stars, planets, and maybe even life. The cosmic inflation that created our universe 13.8 billion years ago might be happening somewhere else at this very moment, manufacturing new realities faster than we can even imagine. Yet for all its success in explaining the universe we observe, inflation remains one of the most controversial theories in cosmology. Because it's almost too successful, it explains everything so well, that some scientists worry it might be unfalsifiable, meaning we might never be able to prove it wrong, which would make it more philosophy than science. And the mechanism that drives inflation, the mysterious inflaton field, remains completely unknown. We have no idea what it is, where it came from, or why it decided to switch on in the first place. But the universe wasn't done with its impossible tricks. After inflation finally ended, and space-time settled into a more reasonable expansion rate, our cosmic story was just getting started. What happened next would involve collisions so violent they make nuclear bombs look like soap bubbles. Our planet's origin story isn't some peaceful cosmic dance where celestial bodies gently came together in harmonious formation. It's the most brutal, violent, apocalyptic tale of destruction and creation that actually happened in our solar system. Picture this absolute nightmare scenario. 40 years ago, our solar system was essentially a cosmic demolition derby, where planet-sized objects were smashing into each other at speeds exceeding 20, releasing energy that would make nuclear explosions look like gentle summer rain. This wasn't just occasional bumping between space rocks. This was systematic, relentless planetary warfare that lasted for tens of millions of years, in what scientists call the most violent period in Earth's entire history. In the early days after our sun ignited and began burning hydrogen in its core, thousands of protoplanets were careening through the inner solar system like cosmic bowling balls, each one growing by systematically devouring smaller objects, or getting completely obliterated in catastrophic collisions that vaporized entire worlds. The early Earth wasn't born as the stable, life-supporting blue marble we know today. It was forged in a hellish series of impacts, so violent that they literally melted our entire planet multiple times over, turning our world into a seething molten magma ocean that extended hundreds of miles deep into the planet's interior. The proto-Earth is locked in a deadly competition for survival during what scientists call the late heavy bombardment period, where massive asteroids and planetesimals the size of modern cities were raining down from space like cosmic artillery shells. Every few thousand years, another mountain-sized chunk of rock and metal would slam into our planet at velocities that defied comprehension, releasing energy equivalent to millions of hydrogen bombs detonating simultaneously across the surface. These impacts were so phenomenally intense, they could literally vaporize entire continents in seconds and send shockwaves racing around the globe multiple times, creating seismic events that make our largest earthquakes look like gentle tremors. But all of that cosmic carnage, the millions of impacts, the vaporized continents, the endless bombardment of space debris, was just the warm-up act for the main event that would define Earth's destiny forever. About 50 to 75 million years after the solar system began forming, when Earth was still a molten hellscape barely recognizable as a proper planet, something unthinkable was racing toward our world through the darkness of space. Hurtling toward the early Earth at a collision course that had been set by gravitational chaos was a Mars-sized protoplanet that scientists have named Theia, after the Greek Titan, who was the mother of the moon goddess Selene. Theia wasn't just another asteroid or comet. This was a fully formed planetary body, roughly half the size of Earth, with its own differentiated structure, including an iron-nickel core, a rocky silicate mantle, and possibly even primitive atmospheres made of hydrogen and helium. For millions of years, Theia had been orbiting peacefully in one of Earth's Lagrange points, those gravitational sweet spots about 60 degrees ahead or behind our planet, where objects can remain stable, like cosmic hitchhikers. But when Theia's growing mass exceeded about 10% of Earth's mass, gravitational perturbations from other planetesimals destabilized its orbit and sent it careening toward our world in what would become the most catastrophic collision in Earth's entire 4.5. The collision that followed wasn't a direct head-on crash that would have completely shattered both worlds into asteroid belt debris, but a glancing blow delivered at approximately a 45-degree angle that made the impact even more devastating than a straight-on hit. When Theia finally struck Earth, about 4.4 billion years ago, it hit at a relatively slow speed of around 9.3 kilometers per second. Slow only by cosmic impact standards, but still fast enough to release energy equivalent to 100 million billion atomic bombs exploding simultaneously. The collision was so monumentally violent that it literally turned both Earth and Theia into liquid rock and metal, creating temperatures that exceeded 7,000 degrees Fahrenheit across both worlds. The impact was so intense that Theia's dense iron core punched straight through Earth's outer layers and plunged deep into our planet's interior, where it merged with Earth's existing core and made it significantly larger and more massive. Meanwhile, the rocky mantles of both worlds mixed together in a cosmic blender of molten silicate material, heated to temperatures that could vaporize copper and zinc instantly. The outer crusts of both planets were completely vaporized on contact and blasted into space as a superheated plasma cloud that glowed brighter than the sun itself. But the most mind-bending part was what happened to the debris ejected from this cosmic catastrophe. We're talking about enough vaporized rock and metal to build mountain ranges as wide as entire continents and tens of thousands of miles high, all launched into Earth orbit in a matter of hours by the sheer violence of the impact. The energy from this collision was so phenomenally intense that it didn't just melt Earth's surface. It turned our entire planet into a spinning ball of molten rock with surface temperatures hot enough to vaporize lead, copper, and even iron. The blast completely stripped away Earth's original atmosphere, replacing it with a toxic soup of vaporized planetary material that glowed white-hot against the cosmic darkness like a second star in our solar system. Earth's rotation, which might have been a leisurely 5-6 hours per day before the impact, was accelerated to a frantic 2-3 hour spin cycle as the collision sent our planet tumbling like a cosmic top knocked sideways by an unimaginable force. The impact was so violent that it tilted Earth's axis and gave our planet the 23.5-degree tilt that creates our seasons today. The debris ejected from this planetary catastrophe formed a massive ring system around Earth that would have made Saturn's rings look pathetic by comparison. This wasn't just cosmic dust and pebbles. We're talking about chunks of molten planet material, some as large as mountains and small moons, all orbiting our devastated world in a chaotic dance of gravity and destruction. The ring system was so hot from the collision that it glowed like a miniature sun, casting eerie red light across the molten Earth below and creating a hellish landscape that defied imagination. Recent computer simulations by NASA scientists suggest that what happened next occurred with shocking speed, within just a few hours to perhaps a few decades, essentially instantaneous in cosmic terms. Gravitational forces began pulling this orbital debris together in a process that was far more violent than anyone previously imagined. The largest chunks of ejected material acted as gravitational seed points, attracting smaller pieces in high-speed collisions that released enough energy to keep the entire forming moon molten like a cosmic foundry, operating at maximum capacity. But here's where the story becomes even more incredible and terrifying. Evidence suggests that Earth initially had not one but two moons orbiting our battered planet. The debris ring was so massive and contained so much material that it formed multiple satellite bodies, each one large enough to create devastating tides that would have moved entire oceans hundreds of miles inland, twice per day. For millions of years, anyone standing on Earth's surface would have seen two massive moons dominating the sky, creating gravitational chaos that made our planet's surface a constantly shifting hellscape of extreme tides and seismic activity. Eventually, these lunar siblings began drifting toward each other due to gravitational interactions, setting up yet another catastrophic collision. When the two proto-moons finally merged, it was another world-ending impact that melted both bodies and reformed them into the single, oversized moon we see today. The collision was so violent that it created the moon's distinctive two-faced appearance, with the heavily cratered far side representing the splattered remains of the smaller moon that got absorbed during the merger. The moon that emerged from this cosmic violence is unlike anything else in our solar system and represents one of the most remarkable coincidences in planetary science. It's proportionally the largest satellite relative to its parent planet of any world we know, so large that astronomers consider Earth and the Moon to be almost a double planet system, rather than a traditional planet-satellite pair. This massive companion isn't just a pretty night light, it's literally what makes Earth habitable for complex life. Without our oversized moon, Earth would be a completely different and probably lifeless world. The moon's gravitational pull stabilizes our planet's axial tilt at 23.5 degrees, giving us regular, predictable seasons instead of chaotic climate swings that would swing from ice ages to scorching heat periods. It also acts as a cosmic brake on Earth's rotation, slowing us down from the frantic 2-3 hour days we'd have without it to our current comfortable 24-hour cycle. Without the moon, Earth would be spinning so fast that hurricane-force winds would be constant, and the extreme centrifugal force would make weather patterns completely unpredictable. Perhaps the most mind-blowing revelation came when Apollo astronauts brought back moon rocks, and scientists analyzed their chemical composition. The isotopic signatures of lunar material are virtually identical to Earth's mantle, proving beyond doubt that the moon isn't a captured asteroid or a separately formed celestial body. Every time you look up at the full moon hanging in the night sky, you're literally seeing a chunk of ancient Earth that was blasted into space 4.4 billion years ago and reassembled in orbit. But wait, there's more evidence that this cosmic catastrophe actually happened. In 2023, scientists at Caltech made a shocking discovery buried deep within our planet. Using seismic wave analysis to peer into Earth's interior, they found two massive blob-like structures in the lower mantle, each roughly twice the mass of the moon, that have completely different compositions from the surrounding rock. These structures, called large low-velocity provinces, have unusually high iron content and appear to be remnants of Theia's mantle that survived the collision and sank to the bottom of Earth's interior, like dense lumps in a lava lamp. Computer simulations confirm that the physics of the giant impact could have created exactly these kinds of dense, iron-rich blobs. Some of Theia's mantle material became incorporated into Earth's interior, where it clumped together and crystallized into the distinct structures we can detect today at the core mantle boundary. The fact that these alien remnants are still intact after 4.4 billion years suggests that the lower mantle wasn't completely melted by the impact, allowing chunks of Theia to survive like cosmic fossils buried deep within our planet. The giant impact hypothesis also perfectly explains several other mysteries about our moon. It explains why the moon has such a tiny iron core compared to Earth, because Theia's heavy iron core sank into our planet during the collision, while the moon formed primarily from the lighter, rocky outer layers of both worlds. It explains why the moon is so severely depleted in volatile elements like water, carbon dioxide, and zinc. The extreme heat from the impact vaporized these materials and sent them flying off into space. And it explains the moon's unusual orbital characteristics, including its relatively large distance from Earth and its slow rotation rate. Some scientists now believe this type of giant impact wasn't unique to Earth, but was actually a common occurrence during the formation of all rocky planets. Computer simulations suggest that massive collisions shaped Mercury, Venus, Mars, and probably most of the rocky exoplanets we're discovering around other stars. The violence that created our moon might be a standard, necessary part of planetary evolution throughout the universe, meaning that large moons like ours could be much rarer than we previously thought. The timing of the Theia impact also had profound consequences for Earth's ability to support life billions of years later. The collision occurred when our planet was still mostly molten, which allowed the iron cores to merge efficiently and create Earth's powerful magnetic field that protects us from deadly solar radiation. If the impact had happened earlier, Earth might not have been large enough to retain its atmosphere after the collision. If it had happened later, the impact might have sterilized a planet that had already developed early life form. But Earth's violent birth was far from over, even after the moon-forming impact. For hundreds of millions of years after Theia's collision, our planet continued to be pummeled by asteroids and comets during the late heavy bombardment period. And buried within this cosmic storm of impacts was the key to solving one of Earth's greatest mysteries: where all of our water came from, and whether life itself might have arrived from outer space. Here's a mind-bending mystery that'll completely transform how you think about every drop of water you've ever touched, swallowed, or swum through. Our blue marble planet was born as dry as a bone. When Earth first formed 4.5 billion years ago from the cosmic debris swirling around the young sun, it was a molten hellscape with absolutely zero water anywhere on its surface or in its atmosphere. The intense radiation from our infant star and the countless volcanic impacts that built our world from colliding planetesimals vaporized any water molecules that might have tried to stick around during the planet-building process. So how in the universe did we end up with 1.386 billion cubic kilometers of ocean covering 71% of our planet's surface? The answer involves one of the most violent, spectacular, and mysterious delivery systems in cosmic history. The water you drink today, the water in your morning coffee, the water coursing through your bloodstream, keeping you alive, every single H2O molecule traveled billions of miles through the freezing vacuum of space before crash landing on Earth in the most dramatic fashion imaginable. But here's where this story becomes a cosmic detective thriller that's been stumping scientists for decades. Researchers have been locked in a heated scientific debate about exactly who delivered our life-giving oceans, and the evidence keeps pointing in shocking directions that challenge everything we thought we knew about our planet's watery origins. For decades, the obvious suspects in this cosmic crime were comets, those spectacular dirty snowballs that light up our night skies with brilliant glowing tails when they venture close enough to the sun's heat. Comets are essentially flying icebergs cruising through space, massive chunks of frozen water mixed with rock dust and organic compounds that formed in the frigid outer reaches of the solar system, where temperatures plunged to nearly absolute zero at -400. It seemed perfectly logical that these cosmic ice delivery trucks could have brought Earth's entire ocean budget during a chaotic period called the Late Heavy Bombardment, when our planet was being pummeled by space debris like a cosmic shooting gallery gone berserk. Picture this absolutely apocalyptic scenario that actually happened in our solar system's violent youth. About 4 billion years ago, the gravitational dance of the giant planets, Jupiter, Saturn, Uranus, and Neptune, went completely haywire as they migrated to their current orbital positions. This planetary shuffle sent millions upon millions of icy comets screaming toward the inner solar system at mind-numbing velocities, exceeding 30,000 miles per hour, turning the region around Earth into a cosmic demolition zone. For hundreds of millions of years, our planet was under relentless bombardment by these cosmic water balloons, each impact releasing explosive energy equivalent to thousands of nuclear bombs, while simultaneously delivering precious frozen cargo to our desperately thirsty world. The scale of this bombardment was beyond anything we can imagine today. Scientists estimate that during the peak of the late heavy bombardment, Earth was being struck by major comet or asteroid impacts every few hundred years, with smaller impacts happening almost daily. The largest of these cosmic projectiles were monsters, hundreds of kilometers across, that would have boiled away entire sections of any existing oceans and shrouded the planet in superheated steam for centuries. Yet each impact also contributed massive amounts of water that would eventually cool and condense to help build the oceans we know today. But when scientists finally got their first real chance to analyze authentic comet water up close, they discovered something absolutely shocking that turned this neat, logical theory completely upside down. In 1986, when the famous Halley's Comet made its spectacular 76-year return to the inner solar system, an international fleet of spacecraft, including Giotto and Vega probes, measured the chemical composition of the comet's water vapor for the first time. The results were devastating to the comet delivery theory. The smoking gun was the ratio of deuterium to regular hydrogen. Deuterium being a rare, heavier isotope of hydrogen that contains an extra neutron in its nucleus. This DH ratio acts like a cosmic fingerprint because deuterium forms more readily in the extreme cold of the outer solar system, meaning objects that formed farther from the sun should have higher concentrations of this heavy water. When scientists analyzed Halley's Comet water, they found it contained about twice as much deuterium as Earth's oceans, which meant that comets like Halley couldn't possibly be the primary source of our water. This discovery sent absolute shockwaves through the scientific community, because their leading theory for 4 decades had just been blown to pieces by hard data. But maybe Halley was just a cosmic oddball. Scientists reason maybe other comets would show different chemical signatures that matched Earth's oceans. They were wrong. Spectacularly wrong. When the spectacular comets Hyakutake and Hale-Bopp blazed across our skies in the 1990s, scientists eagerly analyzed their water vapor using ground-based telescopes and found the same devastating pattern. Way too much heavy water to match Earth's ocean. Comet after comet showed deuterium levels roughly double what we find in terrestrial water. Every new measurement was another nail in the coffin of the comet delivery theory. The final, crushing blow to comet supporters came in 2014, when the European Space Agency's groundbreaking Rosetta spacecraft spent 2 years analyzing Comet 67P Churyumov-Gerasimenko in excruciating detail. This mission was supposed to finally solve the mystery of Earth's water origins by getting up close and personal with a comet from the Kuiper Belt. Instead, the results were absolutely devastating. 67P's water had 3 times more deuterium than Earth's oceans. If comets had delivered all our water, our oceans would be chemically completely different from what we actually observe across the planet. Using these comet deuterium ratios, mathematical models showed that traditional long-period comets from the Oort cloud could have provided less than 10% of Earth's total water budget. The numbers simply didn't add up. Something else had to be responsible for delivering the vast majority of our planet's oceans. And that something had to have a deuterium signature that perfectly matched what we find in Earth's water today. But here's where this cosmic mystery takes a shocking, completely unexpected twist that blindsided even the most experienced planetary scientists. The real water delivery heroes turned out to be asteroids, those supposedly dry, barren chunks of rocky debris that most people think of as lifeless space rocks floating aimlessly through the void. This discovery completely stunned the theodosic community, because asteroids form much closer to the Sun in the inner solar system, where the intense stellar radiation should have vaporized any water molecules billions of years ago. The breakthrough that revolutionized our understanding came when scientists started systematically analyzing carbonaceous chondrite meteorites, fragments of ancient water-rich asteroids that occasionally crash into Earth as shooting stars. When researchers at institutions like Brown University and NASA's Johnson Space Center started crushing these seemingly dry, unremarkable-looking space rocks and heating them in high-temperature laboratory ovens, something absolutely incredible happened that nobody was prepared for. Massive clouds of water vapor came pouring out of these dry asteroid samples, far more water than anyone had ever expected to find locked inside a rocky meteorite. These asteroid fragments contained up to 20% water by weight, not as liquid water or ice that you could see, but as water molecules chemically bound to the rock's complex mineral crystal structure. When heated to temperatures that simulate the intense conditions of asteroid impacts, this bound water breaks free from its mineral prison and becomes available to form rivers, lakes, and eventually vast oceans. Even more shocking than the sheer quantity of asteroid water was its chemical composition. The deuterium to hydrogen ratio in these carbonaceous meteorite samples was a near-perfect match for Earth's oceans. After decades of failed attempts to connect comet water to terrestrial water, scientists had finally found their smoking gun, and it came from the most unlikely source imaginable. The evidence became absolutely overwhelming when Japan's ambitious Hayabusa 2 spacecraft returned pristine samples from asteroid Ryugu in December. This was the first time scientists had ever analyzed uncontaminated asteroid material that hadn't been altered by passage through Earth's atmosphere. Chemical analysis of Ryugu's samples revealed that the asteroid's water signature matches Earth's oceans almost exactly, and more importantly, the asteroid contains enough chemically bound water to account for a significant fraction of our planet's total water budget. NASA's OSIRIS-REx mission to near-Earth asteroid Bennu provided even more compelling evidence when it returned samples in September 2023. Not only did Bennu contain abundant water, locked in clay mineral, but the asteroid also harbored a treasure trove of organic compounds, including amino acids and other carbon-based molecules that could have been the building blocks for both Earth's oceans and potentially even the first primitive life forms. But the most mind-blowing revelation came when scientists began to comprehend the absolutely staggering scale of the cosmic water bombardment that shaped our planet. During the late heavy bombardment period, between 4.1 and 3.8 billion years ago, Earth was being hammered by water-rich asteroids on an almost daily basis. We're talking about impacts involving objects ranging from car-sized chunks to asteroid monsters, hundreds of miles across, each one carrying enough chemically bound water to fill entire lake systems and inland seas. Recent computer simulations have revealed that these ancient impact events were incredibly efficient at delivering water to Earth's surface in a process that was both violent and elegant. When a water-rich carbonaceous asteroid slams into a planet at cosmic velocities exceeding 20 kilometers per second, the collision creates such intense heat and pressure that it literally melts both the asteroid and surrounding planetary rock, releasing all the chemically bound water in explosive fashion, like a cosmic pressure cooker. Studies by researchers at the Southwest Research Institute show that impact melts and breccias, the fractured rock created by these collisions, can capture and retain up to 30% of the water carried by carbonaceous asteroid projectiles. This means that even relatively small asteroid impacts could deliver massive amounts of water that would immediately become available to begin the long process of forming rivers, lakes, and eventually the global ocean system that makes Earth unique in our solar system. The asteroid delivery theory also elegantly solves another major puzzle that had been tormenting planetary scientists: the precise timing of water arrival on our planet. Geological evidence from some of Earth's oldest rocks shows that liquid water existed on our planet as early as 4.4 billion years ago, just 100 million years after the catastrophic moon-forming impact with Theia. Traditional long-period comets from the distant Kuiper Belt and Oort cloud wouldn't have started arriving in large numbers until much later in Earth's history, but water-rich asteroids were being scattered toward the inner planets much earlier during the chaotic period, immediately following planetary formation. But here's where this already incredible story becomes even more mind-bending and cosmic in scope. Scientists studying white dwarf stars, the collapsed ultra-dense remnants of dead sun-like stars, have found compelling evidence that asteroid water delivery isn't unique to our solar system, but is actually a common process happening throughout the galaxy right now. Using powerful ground-based telescopes to analyze the atmospheric composition of these stellar remnants, researchers have detected the distinctive chemical signatures of water-rich asteroids being gravitationally torn apart and consumed by white dwarf stars and other stellar systems. One white dwarf star, designated SDSS J2425226, located about 1,200 light-years from Earth, showed unmistakable evidence of having recently devoured a water-rich asteroid comparable in size to Ceres, the largest asteroid in our solar system at 5 and 8. The amount of water detected in this distant star's atmosphere was equivalent to 35% of all the water contained in Earth's oceans. This extraordinary discovery suggests that water-rich asteroids are incredibly common throughout the galaxy, and that the same violent process that gave Earth its life-sustaining oceans might be happening around countless other stars at this very moment. The implications of this galactic water discovery are absolutely staggering for astrobiology and the search for life beyond Earth. If asteroid water delivery is indeed a standard, common process throughout the universe, it means that rocky exoplanets orbiting other stars could regularly receive massive water deliveries that create conditions suitable for life as we know it. The building blocks for habitable worlds, abundant liquid water oceans, might be getting scattered across the galaxy on a routine basis by cosmic bombardment events, similar to what happened on Earth 4 billion years ago. Recent breakthrough computer simulations have revealed just how spectacularly violent and dramatic these ancient water deliveries really were. When a large water-rich asteroid impacts a planet, it doesn't just gently splash down like a cosmic raindrop. The collision creates a massive fireball that instantly vaporizes both the entire asteroid and a huge chunk of the planet's surface, sending superheated steam and molten rock fountaining hundreds of miles up into the atmosphere. In apocalyptic geysers, as this vaporized material slowly cools over months or years and begins falling back to the surface, it creates torrential global rains that can persist for decades or even centuries. But perhaps the most shocking recent development in this ongoing scientific detective story came in 2024 and 2025, when new cutting-edge research began challenging the complete dismissal of comets as water sources. Scientists reanalyzing data from multiple comet missions, including the Rosetta spacecraft and ground-based observations, discovered that previous measurements might have been significantly contaminated by dust particles from the comet's nucleus, potentially skewing the critical deuterium readings that had seemed to rule out cometary water delivery. When researchers from NASA's Goddard Space Flight Center and other institutions corrected for this dust contamination using more sophisticated analysis techniques, they found that certain Jupiter family comets, including the spectacular Devil Comet 12P Pins-Brooks, observed in 2024, showed deuterium ratios much closer to Earth's oceans than anyone had previously realized. The ALMA telescope observations of 12P Pins-Brooks revealed water with a deuterium signature that was virtually indistinguishable from terrestrial ocean water. This means we might be witnessing the emergence of a more complex hybrid model, where both water-rich asteroids and specific types of comets contributed to Earth's total water budget through different phases of our planet's violent early history. Some Jupiter family comets that formed in the outer solar system but had their orbits altered by gravitational encounters with the giant planets might have delivered water with the perfect chemical composition to match what we find on Earth today. The story of our planet's water origins keeps evolving and becoming more nuanced as new evidence emerges from increasingly sophisticated space missions and laboratory analyses. But what's absolutely clear is that Earth's life-sustaining oceans arrived through the most violent, spectacular, and dramatic delivery system imaginable. Cosmic impacts that would have turned our early world into a hellish landscape of superheated steam, molten lava flows, and torrential acid rains that persisted for millions of years, eventually cooled and stabilized to become the serene blue oceans that harbor all known life in the universe. But water wasn't the only precious cargo these cosmic delivery vehicles brought to our planet during the late heavy bombardment. Hidden within the chemical composition of both water-rich asteroids and comets were complex organic molecules, amino acid, and other carbon-based compounds that would become the fundamental building blocks for something even more incredible than oceans: the mysterious emergence of life itself from the most unlikely and extreme environments on early Earth. Here's a mind-bending revelation that'll completely shatter your assumptions about how life began on our planet. The first living creatures on Earth didn't emerge in shallow tropical tide pools, basking in warm sunlight like some peaceful Garden of Eden scenario that scientists theorized for decades. Instead, life exploded into existence in the most extreme, hostile, and unlikely environment imaginable, in the pitch-black abyss of the ocean floor, miles beneath the surface where crushing pressure would instantly kill any surface creature, where superheated water loaded with toxic chemicals erupts from cracks in the Earth's crust, at temperatures exceeding 400 degrees Celsius, that would instantly boil your blood. These underwater volcanic chimneys, called hydrothermal vents, exist in a realm so alien and extreme that they make the surface of Mars look like a tropical vacation resort by comparison. Picture this absolutely incredible scene unfolding 4 billion years ago, in the crushing darkness of the primordial ocean, where no sunlight has ever penetrated. towering mineral chimneys, reaching hundreds of feet into the water column, belching massive clouds of superheated water, rich in hydrogen sulfide, methane, and dissolved heavy metals, creating an underwater landscape that resembles something from the most nightmarish science fiction movie ever conceived. The water temperatures around these volcanic outlets can exceed 400 degrees Celsius, hot enough to melt lead, zinc, and copper, while the crushing hydrostatic pressure at these abyssal depths is hundreds of times greater than what any surface creature could survive. The chemical composition of the water would be instantly lethal to most modern life forms, containing concentrations of hydrogen sulfide, ammonia, and heavy metals that would poison any organism adapted to surface conditions. Yet somehow, in this seemingly hellish environment that defies every assumption about what life requires to survive, the most remarkable transformation in the entire 13.8 billion year history of the universe was about to unfold: the emergence of self-replicating chemistry that would eventually give rise to every living thing on Earth. The breakthrough discovery that completely revolutionized our understanding of life's origins happened in February 1977, when scientists aboard the revolutionary deep-sea submersible Alvin made an expedition to study underwater volcanic activity along the Galapagos Rift, expecting to find nothing but barren rock and toxic water in the lifeless depths. What they discovered instead defied everything biologists thought they knew about the fundamental requirements for life on any planet. Instead of the sterile, lifeless seafloor they expected based on decades of scientific theory, they found thriving ecosystems, teeming with bizarre creatures, unlike anything that had ever been discovered on Earth's surface. The alien menagerie they encountered seemed to come from another planet entirely. Giant tube worms, reaching 8 feet in length, with blood-red plumes and no mouths, stomachs, or any visible way of obtaining food. Ghostly white crabs scuttling across beds of black volcanic rock. Colonies of bacteria forming thick, colorful mats that had never seen a single photon of sunlight in their entire evolutionary history. Clams the size of dinner plates clustering around the volcanic vents. All of these creatures were flourishing in conditions that should have been completely incompatible with life as scientists understood it. But the most shocking discovery was how these creatures managed to survive in such an extreme environment. Unlike every other ecosystem on Earth that depends directly or indirectly on photosynthesis and energy from the sun, these deep-sea communities were powered entirely by chemosynthesis, the ability to extract usable energy from chemical reactions involving hydrogen sulfide and other volcanic gases that would be deadly poison to surface life. These organisms had evolved a completely alien form of metabolism that could not only survive, but actually thrive in conditions that would instantly kill virtually every other life form on the planet's surface. This revolutionary discovery sent absolute shockwaves through the global scientific community, because it proved that life didn't need sunlight, oxygen, moderate temperatures, or any of the supposedly essential conditions that biologists had assumed were necessary for habitability. If complex multicellular life could thrive in such extreme conditions in the modern world, scientists began wondering if similar environments might have been where life first began emerging from non-living chemistry billions of years ago, during Earth's violent youth. The more researchers studied these otherworldly underwater volcanic systems, the more they realized that hydrothermal vents possessed all the essential ingredients and energy sources needed to jumpstart the transition from simple chemistry to the complex biochemistry that characterizes living organisms. Unlike the surface environment, which was constantly being sterilized by asteroid impacts during the late heavy bombardment, the deep ocean floor provided stable conditions where chemical evolution could proceed uninterrupted for millions of years. Recent groundbreaking research by NASA's Jet Propulsion Laboratory has provided absolutely stunning experimental evidence that hydrothermal vents could indeed manufacture the fundamental building blocks of life from nothing more than volcanic gases and seawater. In sophisticated laboratory experiments designed to precisely recreate the temperature, pressure, and chemical conditions that existed at ancient seafloor vents, scientists mixed superheated water with crushed basalt rock and various dissolved minerals under the crushing pressures found at abyssal depths. The results were absolutely remarkable and exceeded every expectation. The chemical reactions spontaneously produced amino acids, the fundamental building blocks of proteins that make up all living things on Earth. Dr. Lori Barge, the lead researcher on this groundbreaking study at JPL, explained that these experiments demonstrated beyond doubt how the ingredients for life could have formed deep in the ocean 4 billion years ago without requiring any external energy source beyond the natural electrochemistry occurring at hydrothermal vents. The implications are absolutely staggering. It means life might have been virtually inevitable once Earth developed oceans and underwater volcanic activity, rather than being some incredibly unlikely cosmic accident. But the most mind-blowing aspect of the hydrothermal vent origin theory isn't just that these environments can create simple organic molecules from inorganic starting materials. It's that they can also spontaneously assemble these molecules into the complex, organized structures that characterize living cells. Researchers at University College London made a revolutionary breakthrough when they successfully created protocells, primitive cell-like structures that can trap and concentrate organic compounds, just like real biological membranes. Laboratory conditions that perfectly replicated the chemistry of alkaline hydrothermal vents. Professor Nick Lane, who led this revolutionary research that fundamentally changed how scientists think about life's origins, discovered that the hot, alk mineral-rich conditions at hydrothermal vents didn't just allow protocell formation to occur. They actually made it significantly easier and more efficient than in any other environment. Scientists have tested. In our experiments, we have created one of the essential components of life under conditions that are more reflective of ancient environments than many other laboratory studies, explained Dr. Sean Jordan, who worked on the groundbreaking protocell experiments that may have recreated the actual birth of cellular life. The secret to how these underwater volcanic systems could have sparked the emergence of life from non-living matter lies in their unique chemistry and energy dynamics that create natural biological processes. Hydrothermal vents generate natural proton gradients, differences in electrical charge across mineral barriers that can power chemical reactions exactly the same way a battery powers electronic devices, or the way cellular machinery powers living organisms today. When hydrogen-rich water from deep within the Earth's crust meets the carbon dioxide dissolved in ancient seawater, it creates thermodynamically favorable conditions where organic molecules can spontaneously form and become increasingly complex without requiring any external energy input. Recent revolutionary research by Professor William Martin and his team at the University of Düsseldorf has revealed that these life-generating chemical reactions don't just happen by random chance. They're thermodynamically favorable, meaning they naturally release energy and want to occur spontaneously under hydrothermal vent conditions. Under the environmental conditions at deep-sea hydrothermal vents, the central biosynthetic reactions of life do not require an external energy source. Martin explained in findings that fundamentally challenge previous theories about life's origin. These core metabolic reactions release energy all by themselves, as long as hydrogen and carbon dioxide are in supply from the volcanic activity. This discovery represents an absolutely revolutionary breakthrough in our understanding of how life could emerge from non-living chemistry, because it demonstrates that the fundamental processes of life weren't some incredibly unlikely cosmic accident that happened once in the universe's history. Instead, the chemistry of life appears to be an inevitable consequence of the natural geochemistry occurring wherever hydrogen-rich fluids from planetary interiors meet carbon dioxide-rich water in the presence of specific minerals found in volcanic systems. The building blocks of metabolism, the fundamental energy harvesting processes that power all living things, emerge spontaneously from the physics and chemistry of hydrothermal vents like a chemical symphony that plays itself whenever the right geological conditions exist. But perhaps the most compelling evidence for the hydrothermal vent origin theory comes from studying the genetics of life itself, using cutting-edge DNA sequencing technology. By analyzing the genetic sequences of thousands of modern organisms from bacteria to humans, scientists have been able to trace backward through evolutionary history, using molecular clocks to reconstruct what the very first life forms might have looked like when they emerged from chemistry 4 billion years ago. The results are absolutely striking and provide powerful support for the vent hypothesis. The most recent common ancestor of all life on Earth appears to have been a thermophilic microorganism, a heat-loving bacterium that thrived in extremely high temperatures, exactly like those found around modern hydrothermal vents. This genetic evidence suggests that not only could life have originated at hydrothermal vents, but that it almost certainly did originate in these extreme environments. Every living thing on Earth today, from the smallest bacteria to blue whales to human beings, carries genetic signatures and metabolic pathways that point directly back to origins in the extreme heat, pressure, and exotic chemistry of underwater volcanic systems. The universal genetic code, the energy storage molecules used by all life, the basic metabolic pathways, all of it traces back to chemistry that first emerged in hydrothermal vent. The hydrothermal vent theory also elegantly solves several major puzzles that have stumped origin of life researchers for decades. First, it explains how primitive life could have survived the catastrophic late heavy bombardment period between 4.1 and 3.8 billion years ago, when massive asteroid impacts were constantly sterilizing Earth's surface and boiling away any oceans that tried to form. Deep-sea hydrothermal vents would have been completely protected from these cosmic catastrophes by miles of overlying water, providing stable refuge environments where early biochemical evolution could persist and gradually become more complex over millions of years. Second, it explains why all living things on Earth use exactly the same fundamental energy storage molecule called ATP, adenosine triphosphate, which works through proton gradients that are identical to the natural electrochemical gradients found at alkaline hydrothermal vents. The cellular machinery that powers modern life appears to be directly descended from the natural chemistry of underwater volcanic systems. Third, it explains why the most ancient and primitive organisms on Earth today are extremophiles that thrive in hot, chemically extreme environments similar to hydrothermal vents. If life originated in moderate surface conditions, we'd expect the most ancient organisms to prefer moderate conditions. But the opposite is true. The deepest branches of the tree of life are dominated by organisms that love extreme heat, pressure, and toxic chemistry. Recent space exploration discoveries have revealed that these life-generating underwater volcanic systems aren't unique to Earth, opening up incredible possibilities for finding life elsewhere in the universe. Multiple space missions have found compelling evidence that Jupiter's moon Europa and Saturn's moon Enceladus both have vast liquid water oceans beneath their icy surfaces, along with active hydrothermal vent systems on their seafloors, powered by tidal heating from their giant parent planets. The Cassini spacecraft detected water vapor, hydrogen gas, and complex organic compounds erupting from spectacular geysers on Enceladus that appear to originate directly from underwater volcanic activity occurring right now. Professor Lane points out the staggering implications. Icy moons of Jupiter and Saturn might also have similarly alkaline hydrothermal vents in their seas, which means these alien worlds could be manufacturing the building blocks of life right now, using exactly the same chemistry that sparked life on Earth billions of years ago. If hydrothermal vents can reliably create life from non-living chemistry under the right conditions, then we might not be alone in the universe. Similar abiogenesis processes could be happening throughout the galaxy wherever rocky planets or moons have liquid water and volcanic activity. But the most mind-bending recent discovery is that hydrothermal vents might have been the birthplace of not just simple organic molecules or primitive protocells, but of the incredibly complex metabolic networks that power all modern life. Researchers studying the 400-plod core biochemical reactions that are universally conserved across all living things from bacteria to plants to animals, have made the shocking discovery that these reactions naturally want to occur in the hydrogen and carbon dioxide-rich environment of hydrothermal vents. This means that metabolism itself, the intricate web of chemical reactions that defines the difference between living and non-living matter, wasn't gradually assembled piece by piece over millions of years of Darwinian evolution, as scientists had assumed. Instead, the basic metabolic pathways that extract energy from the environment and use it to build complex molecules emerged spontaneously from the natural geochemistry, hydrothermal vents, like a chemical symphony that plays itself whenever volcanic gases meet seawater. Under the right conditions, the implications are absolutely staggering for astrobiology and our understanding of life in the universe. Life might not be an incredibly rare, cosmic accident that happened once on Earth through an almost impossible series of coincidences, but rather an inevitable consequence of planetary chemistry that occurs routinely wherever rocky worlds have liquid water and volcanic activity. The universe might be absolutely teeming with life forms that originated in underwater volcanic systems, similar to Earth's hydrothermal vents, from the subsurface oceans of icy moons to potentially habitable exoplanets orbiting other stars. Recent discoveries have also revealed that modern hydrothermal vents continue to be laboratories for chemical evolution, potentially creating new organic compounds and even primitive lifelike structures. Scientists studying the mineral deposits around active vents have found microscopic channels and pores that can concentrate organic molecules and generate electrical currents, similar to biological systems. These lifelike nanostructures might represent ongoing examples of the same processes that led to life's origins billions of years ago. But even more incredible is the growing body of evidence that these ancient underwater volcanic systems didn't just create the first primitive life forms 4 billion years ago. They established the fundamental energy systems, metabolic pathways, and cellular architecture that still power every living thing on Earth today. The proton gradients that power our mitochondria, the metabolic pathways that extract energy from food and oxygen, the basic electrochemistry that keeps our neurons firing and our hearts beating. All of it traces back to reactions that first occurred in the superheated chemical chaos of hydrothermal vents during Earth's violent youth. Modern research is revealing that the connection between life and hydrothermal systems goes even deeper than anyone imagined. The iron-sulfur clusters that are essential components of many enzymes appear to be direct descendants of iron-sulfur minerals found in vent systems. The carbon fixation pathways used by the most ancient organisms are nearly identical to abiotic carbon fixation reactions that occur naturally at vents. Even the lipid molecules that form cell membranes can be synthesized under hydrothermal conditions. As we uncover more evidence for hydrothermal vent origins, we're not just learning about the ancient past, we're discovering that the alien world of underwater volcanic systems continues to influence life on Earth today and might hold the keys to finding life throughout the cosmos. These discoveries are fundamentally changing how we think about habitability, showing that life can emerge and thrive in environments that seem completely hostile to our surface-based perspective. But while life was taking its first tentative steps in Earth's primordial oceans, powered by the exotic chemistry of underwater volcanoes, cosmic forces operating on unimaginably vast scales were already setting in motion the ultimate fate of everything we see around us. The same universe that created the conditions for life's emergence was simultaneously writing the script for its own ending. Here's the ultimate cosmic horror story that'll keep you awake at night, contemplating the absolute meaninglessness of existence. Everything you see around you, everything you've ever loved, every achievement in human history, every star that lights the night sky, every galaxy that spirals through space, every atom that makes up your body, all of it is doomed to complete and utter annihilation. Not just individual deaths, like organisms experience, but the total extinction of reality itself, the universe that gave birth to space, time, matter, energy, and consciousness, is writing its own death certificate in the language of physics, and scientists have figured out exactly how this cosmic execution will unfold over mind-bending timescales. After spending 13.8 billion years expanding, cooling, and creating the incredible complexity we see today, the universe is already showing signs of terminal illness that will lead to one of three possible endings, each one more terrifying and absolute than the last. These aren't just abstract theoretical possibilities debated by physicists in academic journals. These are inevitable consequences of the fundamental laws of physics that govern our reality, and one of these scenarios will definitely happen. The most likely scenario based on current observations is called the Big Freeze, heat death, or Big Chill, a slow, agonizing cosmic starvation that will stretch across trillions upon trillions of years. But don't let the extended timeline fool you into thinking this is somehow less horrifying, or that humanity might find some way to escape. This isn't a quick, merciful end like a supernova explosion or gamma ray burst. It's the most drawn-out death scene imaginable, where the universe slowly suffocates in its own expansion until every last spark of energy is extinguished forever in a cosmos that reaches maximum entropy. Picture this nightmare scenario unfolding over incomprehensible timescales that make the entire history of human civilization look like a single heartbeat. The universe continues expanding at an ever-accelerating rate, driven by the mysterious dark energy that makes up 68% of everything that exists, but that we still don't understand. This dark energy acts like a cosmic repulsive force, pushing space itself apart faster and faster with each passing moment. As the fabric of space-time stretches, galaxies drift further and further apart until they become isolated islands in an ever-growing ocean of absolute nothingness. The cosmic separation becomes truly heartbreaking when you realize what this means for any future civilizations. Within the next few billion years, the accelerating expansion will push distant galaxies beyond our observable horizon forever. Any galaxy that isn't already gravitationally bound to our local group, which includes only the Milky Way, Andromeda, and a handful of dwarf galaxies, will be carried away by expanding space until their light can no longer reach us. Future astronomers will look up at a night sky containing only a few dozen galaxies, with no way to know that billions of other galaxies once existed, but are now racing away faster than the speed of light. But this cosmic loneliness is just the beginning of the universe's death spiral. Within the next 100 trillion years, a time span so vast that it contains more than 7,000 times the entire history of the universe so far, every star in every galaxy will burn through its nuclear fuel and die. This stellar apocalypse will unfold in stages that each last longer than human minds can comprehend. First, the massive blue supergiants will exhaust their fuel in just a few million years, exploding as supernovas or collapsing into black holes. These stellar monsters burn so bright and hot that they consume their hydrogen fuel at prodigious rates, living fast and dying young in cosmic terms. Their deaths will light up their host galaxies with brilliant explosions, visible across billions of light years. But each supernova represents another irreplaceable energy source gone forever. Next, medium-sized stars like our Sun will begin their death throes. In about 5 billion years, the Sun will exhaust the hydrogen in its core and begin burning helium, causing it to expand into a red giant that will likely engulf Mercury, Venus, and possibly Earth. After a few 100 million years as a red giant, the Sun will shed its outer layers and become a white dwarf, a dense, hot stellar corpse about the size of Earth, but containing the mass of the Sun. This white dwarf will slowly cool over billions of years, gradually fading from white hot to red to brown to black as it radiates away its remaining heat. But the red dwarf stars will be the last survivors in this cosmic funeral procession. These small, dim stars burn their nuclear fuel so slowly and efficiently that they can continue shining for 10 trillion years, more than 700 times longer than the universe has already existed. When the final red dwarf finally exhausts its nuclear fire and fades to a cold, dark ember, sometime in the incomprehensibly distant future, the universe will enter what cosmologists call the degenerate era. No new stars will ever form again, because all the free hydrogen and helium gas needed for star formation will have been locked up in stellar remnants or scattered so thin by cosmic expansion that gravity can no longer pull it together into star-forming clouds. The stellar graveyard that follows will be haunting beyond description. The universe will be filled with the cold corpses of dead stars, white dwarfs, neutron stars, and black holes drifting through space in the darkness. Planets will continue orbiting these dead stars for a while. But even planetary systems are not permanent structures. Over trillions of years, gravitational interactions between stars will gradually perturb planetary orbits, causing planets to either spiral into their dead stars or get flung out into interstellar space as frozen, lifeless worlds. But the cosmic death spiral is just getting started at this point. Over the next quadrillion years, that's 1,000 trillion years, or about 70 million times longer than the universe has already existed, gravitational interactions will tear apart even the largest structures in the cosmos. The process happens gradually through what astronomers call gravitational scattering. Every time two stars pass close to each other, one gets a slight gravitational boost, while the other loses energy. Over enormous timescales, this leads to the complete dissolution of all gravitationally bound structures. Star clusters will evaporate as their member stars are flung into space by repeated gravitational encounters. Galaxies will lose their spiral structure as stars are scattered into random orbits. Solar systems will be ripped apart as planets are ejected from their orbits. Even the closest binary star systems will eventually be disrupted. The organized structures that took billions of years to form through the patient work of gravity will be systematically dismantled by the same gravitational forces that created them. During this unimaginably long degenerate era, the universe will be dominated by black holes, the only objects massive enough to resist complete gravitational dissolution. But even these cosmic monsters are not immortal. Stephen Hawking's revolutionary discovery in the 1970s showed that black holes slowly evaporate by emitting radiation. And this Hawking radiation means that even the largest black holes have expiration dates. The evaporation process is agonizingly slow for large black holes. A black hole with the mass of our Sun would take about 10 to 67 years to completely evaporate. That's a 1 followed by 67 zeros. A number so astronomically large that it's essentially meaningless to human comprehension. To put this in perspective, if you wrote out this number with 1 digit per atom, you would need more atoms than exist in the entire observable universe. But the supermassive black holes that anchor the centers of galaxies are even more long-lived, because larger black holes evaporate much more slowly than smaller ones. The supermassive black hole at the center of our Milky Way galaxy, which weighs about 4 million times more than the Sun, will take approximately 100 years to disappear through Hawking radiation. This is longer than the number of atoms in the observable universe, longer than any meaningful measure of time that humans have ever conceived. Yet eventually, even this cosmic giant will emit its final particle of Hawking radiation and vanish forever, leaving behind nothing but empty space. When the last supermassive black hole finally evaporates with a final puff of Hawking radiation, sometime in the impossibly distant future, the universe will enter its terminal phase, the dark era. All that will remain is a thin soup of elementary particles scattered across distances so vast that they will almost never interact with each other. Photons gradually losing energy as space expands, neutrinos that barely interact with anything, electrons and positrons occasionally meeting and annihilating each other. In brief flashes of light, and maybe some exotic particles that we haven't discovered yet. The temperature of space will approach absolute zero as the cosmic microwave background radiation gets stretched to ever longer wavelength by the expanding universe. No chemistry will be possible, because atoms cannot form at such low temperatures and density. No complexity can emerge, because there's no available energy to drive the processes that create order. The universe will have reached maximum entropy, a state of perfect, eternal thermodynamic equilibrium where nothing interesting can ever happen again. But here's the most chilling part of the Big Freeze scenario. Even in this dead universe, time will continue to flow forever. Consciousness, if any still exists in some form we can't currently imagine, would experience an eternity of perfect stillness, broken only by the incredibly rare quantum fluctuations that might occasionally create brief sparks of order before they immediately dissolve back into random chaos. It's not just death, it's eternal death, stretching across infinite time in a cosmos that has completely forgotten what it ever meant to be alive, complex or beautiful. Some physicists have speculated about even stranger possibilities in this far future. The Poincare recurrence theorem suggests that given infinite time, any finite system will eventually return to any previous state. This means that in the unimaginably distant future, after 10, 20 years or more, thermal fluctuations might randomly recreate complex structures, including exact copies of everything that ever existed. You, reading these words right now, might randomly reassemble from quantum fluctuations in the dead universe, along with your entire solar system, galaxy and observable universe, in a process that would repeat infinitely many times across eternity. However, the Big Freeze isn't the only way our cosmic story could end. Scientists have identified two other scenarios that are arguably even more terrifying, because they're more violent, immediate, and involve the active destruction of reality, rather than its gradual decay. The second possibility is called the Big Rip, and it represents the universe committing suicide through its own runaway expansion. The Big Rip scenario hinges on a terrifying possibility about the nature of dark energy, the mysterious force that's currently accelerating the expansion of space itself at an ever-increasing rate. Right now, dark energy appears to behave like Einstein's cosmological constant, providing a steady repulsive force that pushes galaxies apart at a constant rate. But what if dark energy isn't actually constant? What if it's getting stronger over time, becoming more powerful and more destructive with each passing moment in a runaway process that eventually overwhelms every other force in nature? This strengthening form of dark energy is called phantom dark energy, and its effects would be catastrophically unstoppable. Recent mathematical models developed by physicist Marcello Visconti at Vanderbilt University suggest that the universe's viscosity, its resistance to being stretched, might actually accelerate this process rather than slow it down. Unlike normal fluids where viscosity creates drag, the viscosity of space-time itself might act like fuel for an expanding universe, making the Big Rip not just possible, but inevitable if dark energy continues to strengthen. The timeline for cosmic disintegration in the Big Rip scenario is measured in billions rather than trillions of years, making it far more immediate than the Big Freeze. First, galaxy clusters would be torn apart as space expands faster than gravity can hold them together. The local group, containing our Milky Way and Andromeda galaxies, would lose its gravitational coherence, and these massive galaxies would begin racing away from each other at increasing speeds. Then individual galaxies would be shredded as dark energy overpowers the gravitational bonds that keep hundreds of billions of stars in stable orbits around galactic centers. The Milky Way's beautiful spiral structure would dissolve as stars are flung away from the galactic center faster than gravity can maintain the delicate orbital mechanics that create spiral arms. Within about 1 billion years of the Big Rip's onset, galaxies as coherent structures would cease to exist. Solar systems would be ripped apart next, with planets flung away from their stars as space itself expands faster than gravity can maintain orbital stability. About 60 million years before the final rip, Earth would be torn away from the Sun and sent careening through interstellar space as a frozen, lifeless world. The moon would be ripped away from Earth's gravitational grip. The asteroid belt would scatter. The entire architecture of our solar system would be destroyed by the expanding space between objects. But the Big Rip doesn't stop at astronomical destruction. It penetrates down to the most fundamental level of reality itself. As dark energy becomes increasingly dominant, it would eventually overcome every force in nature, starting with gravity and working its way down through the hierarchy of physical interactions. About 30 minutes before the final moment, Earth itself would be torn apart as expanding space overpowers the gravitational force holding our planet together. The solid rock beneath our feet would literally rip apart as space expands faster than the speed at which pressure waves can travel through matter. In the final seconds, even molecules would be torn apart as space expands faster than chemical bonds can maintain their integrity. Water molecules would split into individual hydrogen and oxygen atoms. The proteins in living cells would unravel. The DNA double helix would be ripped apart. Complex chemistry would become impossible as the distances between atoms grow faster than electromagnetic forces can bridge them. Finally, even atoms themselves would be shredded as dark energy overpowers the electromagnetic force that holds electrons in orbit around atomic nuclei. In the last microseconds, atomic nuclei would be ripped apart as space expansion becomes so violent that it tears apart the strong nuclear force that binds protons and neutrons together. Matter itself would cease to exist as a meaningful concept, leaving behind nothing but isolated subatomic particles scattered across an infinitely expanding void, where the very notion of distance becomes meaningless. The most psychologically disturbing aspect of the Big Rip is that conscious beings might be aware of the approaching doom as it unfolds over billions of years. Unlike the slow heat death that takes longer than any conceivable civilization could survive, the Big Rip could happen while advanced civilizations still exist and are capable of observing the process. Imagine watching the night sky as distant galaxies, one by one, get stretched beyond visibility, their light redshifted to infinite wavelengths as space carries them away faster than light itself can travel. Imagine seeing your own solar system begin to destabilize as space itself becomes your enemy, working against the very forces that make planets, stars, and life possible. The final moments would be a cosmic horror movie, where the laws of physics themselves turn malevolent, where the expansion of space, the same process that allowed galaxies to form and life to evolve, becomes an unstoppable destructive force that literally tears apart the fabric of reality. The third and perhaps most philosophically disturbing scenario is the Big Crunch, a cosmic reversal that would see the universe collapse back into the same type of singularity from which it originally emerged. While current observations suggest this is the least likely outcome given the discovery of accelerating expansion, it remains a theoretical possibility. If the total amount of matter and energy in the universe is greater than we currently estimate, or if dark energy somehow weakens, disappears, or even reverses its effects over cosmic time. In the Big Crunch scenario, the expansion of the universe would gradually slow down due to gravitational attraction, eventually stop completely, and then reverse into a contraction phase. This wouldn't happen for many billions of years, but once it began, the process would be as inevitable and unstoppable as the original Big Bang was. Galaxies that are currently racing away from each other would begin falling back together under the irresistible pull of gravity, starting a cosmic collision course that would end with everything that has ever existed getting crushed back into an infinitely dense point. The cosmic microwave background radiation that currently bathes the universe in near absolute zero temperatures would begin heating up as space contracts and compresses all the electromagnetic energy within it. The universe would literally reverse its thermal history, becoming hotter and denser as it shrinks. The night sky would gradually brighten as distant galaxies are compressed closer together, their light blue shifted to higher energies as space contracts, rather than expands. As the contraction accelerates, the cosmic microwave background would shift from its current radio wavelengths through infrared, visible light, ultraviolet, and eventually to X-rays and gamma rays. As space contracts and heats the radiation to ever higher temperatures, the universe would become so hot that stars would be unable to radiate away their heat faster than the ambient temperature of space itself is rising. Even the coldest regions of interstellar space would become hotter than the cores of the most massive stars. The final stages of the Big Crunch would be absolutely apocalyptic and would unfold over millions of years of cosmic horror. Galaxies would merge and collide in a cosmic traffic jam as space contracts faster than they can avoid each other. The beautiful spiral structures of galaxies like the Milky Way would be destroyed in massive galactic collisions that fling billions of stars into chaotic orbits. Star formation would cease as the universe becomes too hot for gas clouds to collapse and condense. Individual stars would be ripped apart by tidal forces as they're compressed into smaller and smaller volumes of space. The nuclear fusion processes and stellar cores would be disrupted by the extreme conditions. Planets would be vaporized by the increasing temperature of space itself, which would eventually exceed the surface temperatures of the hottest stars. Even the hardest materials would melt and then vaporize as the universe approaches the same extreme conditions that existed in the first moments after the Big Bang. In the final moments, even atomic nuclei would break down as the temperature and density of the contracting universe recreate the conditions of the primordial fireball. Protons and neutrons would be torn apart into their constituent quark. The fundamental forces of physics would merge back into the unified force that existed only in the first fractions of a second after the original Big Bang. Space and time themselves would break down as the universe contracts toward the same type of singularity from which it originally emerged. But here's the truly mind-bending aspect of the Big Crunch. Time itself would begin to behave differently as the universe contracts, just as the expansion of space dilates time from our perspective, making distant events appear to happen more slowly. The contraction of space would compress time, making the final moments of universal collapse appear to happen incredibly quickly to any hypothetical observers who somehow survived that long. The universe would end, not with the whimper of heat death, but with the same type of violent singularity that created it in the first place. Some physicists have proposed that the Big Crunch might not be the absolute end of existence, but rather the beginning of a new cosmic cycle. In the Big Bounce theory, the universe would collapse down to a singularity and then immediately explode outward again in a new Big Bang, creating an endless cycle of cosmic death and rebirth, stretching across eternity like an infinite cosmic heartbeat. If this cyclical model is correct, our universe might just be one iteration in an infinite series of universes, each one living and dying and being reborn in an eternal cosmic recycling program. This cyclical universe model has profound philosophical implications because it suggests that everything that has ever happened, including your birth, your life, your death, and every word you're reading right now, has happened infinitely many times before and will happen infinitely many times in the future. Every possible variation of cosmic history would play out across infinite cycles, creating a multiverse of possibilities where every conceivable universe eventually comes into existence. However, recent astronomical observations have dealt what appears to be a fatal blow to Big Crunch scenarios. The discovery in 1998 that the universe's expansion is actually accelerating, driven by dark energy, strongly suggests that there isn't enough matter and energy in the universe to eventually overcome this acceleration and reverse the expansion. Unless dark energy mysteriously disappears or reverses its effects, and we have no theoretical reason to expect this to happen, the universe appears destined for either the slow heat death of the Big Freeze or the violent destruction of the Big Rip. But there's a fourth possibility that's even more terrifying than the three main scenarios, because it could happen at any moment without warning. Vacuum decay also known as the Big Slurp. This theory, which emerges from our understanding of quantum field theory and particle physics, suggests that our entire universe might be existing in what physicists call a false vacuum state, a configuration that appears stable, but is actually balanced precariously on the edge of a cosmic cliff. Think of our current vacuum state like a ball sitting in a shallow depression on a hillside. The ball appears stable and could sit there for an extremely long time, but if it gets nudged hard enough, it could roll down to a much deeper valley, representing a lower energy true vacuum state. If our universe suddenly transitions to this lower energy vacuum state, a bubble of destruction would form at some random point in space and expand outward at the speed of light, completely rewriting the laws of physics and instantly obliterating everything in its path. The most chilling aspect of vacuum decay is that it could happen at any moment, without any warning whatsoever. Unlike the other scenarios that unfold over billions or trillions of years, giving hypothetical advanced civilizations time to prepare or adapt, vacuum decay would give us absolutely no time to understand what was happening before we ceased to exist. One moment, the universe would be operating according to the familiar laws of physics that have governed reality for 13.8 billion years. And the next moment, those laws would be completely rewritten by an expanding bubble of alien physics, racing toward us at 300,000 kilometers per second. Current research using particle accelerators like the Large Hadron Collider is actually trying to determine whether our vacuum state is truly stable or merely metastable. Some theoretical calculations based on the measured mass of the Higgs boson and other fundamental constants suggest that our vacuum could indeed be metastable, meaning vacuum decay is not just possible, but might be inevitable, given enough time. The timeline could be 100 years in the future, making it irrelevant compared to other cosmic death scenarios. Or it could theoretically happen tomorrow. The quantum mechanical nature of the transition makes it fundamentally unpredictable. What makes vacuum decay particularly terrifying is that the new physics inside the expanding bubble might not allow for the existence of atoms, molecules, or any form of complexity. The fundamental constants that determine how particles interact, the strength of electromagnetic force, the mass of electrons, the way quarks bind together to form protons and neutrons, could all be completely different inside the true vacuum bubble. Matter as we know it might simply cease to exist, replaced by exotic forms of matter and energy governed by alien physical laws. Recent discoveries about the nature of dark energy have added new layers of uncertainty to all these cosmic death scenarios. The Dark Energy Spectroscopic Instrument, DISI, which has been mapping the expansion history of the universe with unprecedented precision, has found hints that dark energy might not be the constant cosmological force that scientists have assumed. Some of their data suggests that dark energy could be changing over time, either strengthening toward a Big Rip scenario or weakening toward a potential Big Crunch. If dark energy is indeed evolving, rather than constant, it dramatically alters the timeline and nature of the universe's ultimate fate. A strengthening dark energy could bring forward the Big Rip scenario by billions of years, while a weakening dark energy might allow gravity to eventually halt expansion and trigger a Big Crunch that seemed impossible based on previous observations. The DISI findings suggest that we may not understand dark energy as well as we thought, and that the universe's death could be more imminent or more complex than any of our current models predict. As we gather more data about dark energy, dark matter, the Higgs field, and the fundamental structure of space-time through increasingly sophisticated experiments and observations, we're discovering that predicting the universe's fate is far more complex than anyone initially imagined. The death of everything might come sooner than we think through vacuum decay or an accelerating Big Rip, or it might be delayed by physics we haven't discovered yet, or it might unfold through some combination of multiple scenarios in a cosmic apocalypse that's beyond our current ability to comprehend. Some of the most cutting-edge theories in physics suggest even stranger possibilities. String theory and quantum gravity models propose that our observable universe might be just one bubble in an infinite multiverse, where new universes are constantly being created through quantum fluctuations while others are destroyed. In this view, the death of our universe wouldn't be the end of everything, but just one event in an eternal cosmic process that creates and destroys universes like waves on an infinite ocean. But regardless of which scenario ultimately claims our particular universe, one thing is absolutely certain, based on everything we understand about physics. Everything that has ever existed or ever will exist within our cosmic horizon is temporary. Every star that shines in the night sky, every planet that orbits those stars, every life form that has evolved or will evolve, every thought that has ever been thought or will be thought, every work of art, every act of love, every moment of consciousness, all of it is destined for complete and utter annihilation. The universe gave birth to atoms and molecules, to stars and planets, to complexity and beauty, to life and consciousness and intelligence. But it's also writing the death certificates for all of these remarkable achievements. We are temporary arrangements of matter and energy that became conscious just long enough to figure out where we came from and where we're going. Brief patterns of information processing that emerged from chaos and will inevitably return to chaos. Yet even in the face of this cosmic doom, there's something profoundly beautiful and meaningful about our situation. In a universe destined for darkness, we are brief candles that learn to appreciate our own light. We are arrangements of atoms that became aware of themselves and curious about their origins and fate. We are the universe's way of understanding itself, even if that understanding is temporary and doomed. And perhaps that fleeting moment of cosmic self-awareness, however brief, in the vast span of time, is the most remarkable and beautiful thing that has ever happened in our corner of reality. After journeying through 13.8 billion years of cosmic history, from the impossible birth of everything from nothing, through the violent formation of our world, to the inevitable death of all existence, we're left with one of the most profound questions any conscious being can ask. What does any of this actually mean for us? Right here, right now, in this fleeting moment of cosmic time. The story we've just explored isn't just an academic exercise in astrophysics and cosmology. It's the ultimate reality check that fundamentally changes everything about how we see ourselves, our problems, our relationships, our planet, and our place in the grand scheme of existence. This is what scientists and philosophers call the cosmic perspective, a radical shift in consciousness that emerges when you truly grasp the scale, age, and violent beauty of the universe we inhabit. It's not just knowing these facts intellectually, like memorizing dates for a history exam. It's the deep, emotional, almost spiritual realization that every atom in your body was forged in the nuclear furnace of a dying star billions of years ago, that the water you drink traveled through the vacuum of space on asteroid impacts to reach Earth, that the ground beneath your feet was assembled from the shattered remains of countless worlds in cosmic collisions that would make our most powerful nuclear weapons look like firecrackers. When you truly absorb the cosmic perspective, something profound shifts in your consciousness that can never be undone. You realize that every human conflict, every political disagreement, every social media argument, every personal worry that keeps you awake at night is playing out on a tiny blue dot, suspended in an incomprehensible vastness that extends for 93 billion light-years in every direction. You understand that all of human history, every war, every empire, every scientific discovery, every work of art, every moment of love and loss, has unfolded in the last 4% of the universe's existence. It's making our entire species a remarkably recent experiment in cosmic consciousness. But here's where the cosmic perspective becomes truly transformative, rather than simply depressing. It doesn't diminish human significance. It recontextualizes it in a way that makes our existence far more remarkable and precious than any Earth-centered worldview ever could. As astrophysicist Neil deGrasse Tyson eloquently explains, When I look up in the universe, I know I'm small, but I'm also big. I'm big because I'm connected to the universe, and the universe is connected to me. You are not separate from the cosmos looking in. You are the cosmos become conscious of itself. Think about this mind-blowing reality. You are a temporary arrangement of atoms that became aware of their own cosmic origins. You are stardust that learned to contemplate stars. You are the universe's way of experiencing itself subjectively, of asking questions about its own nature, of creating art and music and poetry about its own beauty and mystery. In a cosmos that appears largely cold and indifferent to conscious experience, you represent something almost impossibly precious. Matter organized in such a way that it can think, feel, love, create, and wonder about its place in existence. The cosmic perspective reveals that consciousness itself might be the rarest and most valuable phenomenon in the entire universe. While we've discovered thousands of exoplanets and confirmed that the basic ingredients for life are common throughout the galaxy, we have yet to find a single confirmed example of consciousness anywhere else in the cosmos. You might be participating in the rarest event in the known universe, the brief moment when matter becomes aware of itself and contemplates its own existence against the backdrop of infinite space and time. This realization completely transforms how we think about human problems and conflicts. The cosmic perspective doesn't make our daily struggles meaningless. It reveals how much energy we waste on tribal divisions and artificial boundaries, when we could be marveling at the incredible fact that we exist at all in a universe that had no obligation to create conscious beings. Every moment you spend hating someone because of their nationality, religion, race, or political beliefs is a moment stolen from the cosmic miracle that both of you represent as conscious participants in the universe's 13.8 billion year journey toward complexity. From the cosmic perspective, the borders drawn on our maps become as arbitrary and temporary as the boundaries between waves on the ocean. We're all fellow travelers on spaceship Earth, hurtling through the galaxy at 67,000 miles per hour, around a star that's racing through space at 514,000 miles per hour, in a galaxy that's moving at 1.3 million miles per hour. Through the expanding universe, every human being you encounter is made from the same stellar materials, powered by the same ancient fusion reactions, carrying the same 3.8 billion year genetic heritage, participating in the same cosmic experiment in consciousness. The cosmic perspective also radically changes how we think about our responsibility to Earth and future generations. When you see our planet as Carl Sagan's pale blue dot, the only known oasis of life in a vast cosmic desert, environmental destruction becomes not just short-sighted, but almost blasphemous. We're not just polluting our backyard, we're potentially destroying the only known example of a life-bearing world in the observable universe. Every species that goes extinct, every ecosystem that collapses, every degree of warming represents an irreplaceable loss in the cosmic experiment of biological complexity. But the cosmic perspective isn't just about environmental responsibility. It's about temporal responsibility as well. When you understand that the atoms in your body have existed for billions of years and will continue existing for billions more after your death, you realize you're just a temporary custodian of these materials. The carbon atoms that form the backbone of your DNA molecules were once inside dying stars, then drifting through interstellar space, then locked in asteroid rock, then dissolved in ancient oceans, then incorporated into countless other life forms before eventually becoming part of you. After your death, these same atoms will be recycled into new forms of organization. Maybe trees, maybe other people, maybe creatures we can't imagine that will exist millions of years in the future. This atomic continuity means that, in a very real sense, death is not the end, but a transformation. Your consciousness, your memories, your personality, these are temporary patterns of information processing that will cease when your brain stops functioning. But the material substrate of your existence, the actual atoms that made your thoughts and experiences possible, are ancient beyond imagination and will continue their cosmic journey Long after your individual pattern has dissolved, you are a temporary eddy in the cosmic river, a brief arrangement of matter and energy that achieved self-awareness before returning to the flow of universal becoming. Understanding this cosmic recycling process can be simultaneously humbling and liberating. It's humbling because it reminds us that we're temporary participants in something vastly larger than ourselves. But it's liberating because it connects us to a story that's infinitely grander and more meaningful than any purely human narrative could be. Your existence is not a random accident, but the culmination of 13.8 billion years of cosmic evolution, from the Big Bang through stellar nucleosynthesis, planetary formation, the emergence of life, and the evolution of consciousness. The cosmic perspective also transforms how we think about time and the urgency of human concerns. When you realize that our sun has been burning for 4.6 billion years and will continue for another 5 billion years, many of our short-term worries begin to seem less overwhelming. This isn't about becoming apathetic or nihilistic. It's about gaining the emotional stability that comes from operating on multiple timescales simultaneously. You can care deeply about immediate human needs, while also maintaining perspective about the longer arc of cosmic evolution. This multi-temporal awareness can actually make you more effective at solving human problems, not less. When you're not consumed by anxiety about temporary setbacks or short-term thinking, you can focus on solutions that work on both human and cosmic timescales. Projects like renewable energy, space exploration, the preservation of knowledge, and the cultivation of wisdom become investments in the cosmic future of consciousness itself. You're not just improving human life, you're helping to ensure that the universe's 13.8 billion year investment in complexity and consciousness continues to pay dividends. The cosmic perspective even changes how we think about individual achievement and legacy. Traditional human measures of success, wealth, fame, power over other people, begin to seem almost comically limited when viewed against the backdrop of cosmic time. But actions that contribute to human knowledge, environmental sustainability, the reduction of suffering, the expansion of consciousness, or the long-term survival of our species, take on profound cosmic significance. When you help someone learn something new, you're participating in the universe's ongoing project of self-understanding. When you create something beautiful, you're adding to the cosmic inventory of organized complexity. When you treat other conscious beings with compassion, you're honoring the incredible rarity and preciousness of awareness itself. Perhaps most importantly, the cosmic perspective offers a radical solution to the existential crisis that can come from contemplating our mortality and the ultimate fate of everything we care about. Yes, the universe will eventually die in heat death, a big rip, or some other cosmic apocalypse. Yes, every individual human life ends in death. But this isn't cause for despair, it's cause for profound appreciation. We get to be conscious participants in the most remarkable story ever told, witnesses to the universe's brief experiment with complexity and awareness. The fact that our existence is temporary doesn't make it less meaningful. It makes it more precious. A sunset is beautiful precisely because it's temporary. Music is moving because each note begins and ends. Love is powerful because life is finite. If we lived forever in a changeless universe, consciousness itself might lose its edge, its urgency, its capacity for growth and surprise. The cosmic perspective suggests that impermanence isn't a bug in the system. It's a feature that makes consciousness possible and meaningful. Moreover, while individual human lives are brief, our participation in cosmic evolution is ongoing. Every discovery we make, every problem we solve, every work of art we create, becomes part of the universe's permanent information structure. The knowledge that atoms can be organized in ways that produce consciousness, that matter can contemplate its own existence, that the universe can understand itself through scientific investigation. These realizations are genuine cosmic achievements that can never be completely erased. Even if our particular civilization ends, even if Earth becomes uninhabitable, Even if our species goes extinct, the patterns of organization we've discovered and the information we've generated become permanent features of the cosmic story. The cosmic perspective also suggests that our individual lives gain meaning, not from permanence, but from participation. You don't need to live forever to matter cosmically. You just need to participate consciously and intentionally in the ongoing cosmic experiment of which you're already a part. Every moment you spend learning something new, you're expanding the universe's self-knowledge. Every act of creation adds to the cosmic inventory of organized complexity. Every expression of love and compassion honors the incredible improbability that conscious beings capable of care exist in this vast cosmos. This participatory view of meaning suggests that our responsibility is not to achieve immortality or permanent significance, but to make our temporary existence count in cosmic terms. We can do this by being curious about the universe that made us, by being creative in ways that add beauty and complexity to existence, by being compassionate toward other conscious beings who share our remarkable situation, and by being good ancestors who leave the cosmic story in better condition for future conscious participants. The cosmic perspective ultimately reveals that we are not insignificant accidents in an indifferent universe. We are the universe becoming conscious of itself, asking questions about its own nature, creating meaning through our choices and actions. In a cosmos that had no obligation to produce awareness, love, creativity, or wonder, we represent something almost impossibly precious and unlikely. We are brief candles that learn to appreciate our own light, temporary patterns of matter and energy that achieve the cosmic miracle of self-awareness. So the next time you look up at the night sky, remember that you're not looking at something foreign and distant. You're looking at your cosmic family, at the stellar nurseries where your atoms were born, at the vast arena in which the most remarkable story ever told continues to unfold. You are not separate from the cosmos, but intimately connected to every part of it, from the smallest quantum fluctuation to the largest galactic supercluster. You carry within yourself the memory of the Big Bang, the heritage of stellar evolution, the legacy of planetary formation, the triumph of life's emergence, and the miracle of consciousness itself. In embracing the cosmic perspective, you don't lose your humanity. You discover what it really means to be human in the context of cosmic evolution. You realize that being human means being the universe become aware of itself, capable of wonder, love, creativity, and the pursuit of truth. And in that realization, even in the face of cosmic vastness and inevitable endings, you can find not despair, but profound meaning, connection, and purpose that transforms everything about how you experience existence itself.